everyone, today we are going to see about the matrices. In that, first we are going to see about types of matrices. First one is a row matrix. So row matrix is a matrix having only one row is called the row matrix. This is the first example, that is A is equal to Aij 1 into 3. So minus 1, 2, 3, there is 3 column and then 1 row is a row matrix of order 1 cross 3. Next, coming to the next example, that is B matrix, which is Bij 1 cross 2. This one is only 2 columns and there is only 1 row. Okay, so that is 1 cross 2 is a row matrix of order 1 cross 2. Now coming to the next one, column matrix. So what is a column matrix? Is a matrix having only one column. So same like a row matrix, it's column matrix. So when you see the example, you can understand. So 3 cross 1. So 3 rows but 1 column, okay, is a matrix of order 1. So any matrix, there is a note, any matrix of order 1 cross 1 can be treated either as a row matrix or a column matrix, okay. So 1 cross 1, if there is any matrix which is having 1 cross 1, that can be treated as a row matrix or else a column matrix. Coming to the next one is the square matrix. So a matrix which has equal number of rows and columns. In a matrix, there should be equal number of rows and columns. And there is another description, a square matrix A of order n cross n, the element A11 means like this, A11, A22 are called the principal diagonals. We can say that as the principal diagonals. So this is how a square matrix look like. So A is equal to Aij 2 cross 2. So you have 2 rows and 2 columns. So that is a square matrix which looks like a square. So that is, so we are calling this as a square matrix. Next one is a diagonal matrix. A square matrix is said to be a diagonal matrix if Aij is equal to 0 and when I is equal to j. So here square matrix, we can, when you see the example, you can clearly understand only the diagonals in a square matrix, only the diagonal will have the numbers. In other places we have 0. So Aij is equal to 0. So this is called the diagonal matrix. Then the next one, the triangular matrix. In a triangular matrix where all the entries above the main diagonals are 0. So above the main diagonal is also all 0. That is called the lower diagonal matrix. This is the lower diagonal matrix. Similarly, if the entries below the main diagonal are 0 is called the upper diagonal matrix. This is an upper diagonal matrix. So why we are saying this is a triangular matrix is when you take this position, it will form a triangle, okay. So when you take this position, it will form a triangle. So we are saying that as a triangular matrix. The next one is a scalar matrix. Here a square matrix, that is square matrix A is equal to Aij n cross n, is said to be a scalar matrix if Aij is equal to 0, if I is equal to j is also 0, if I is not equal to j is also 0. Now what is the thing is, a scalar matrix is a diagonal matrix in which all the entries along the diagonals are equal. So when you see here it's a 2 cross 2 square matrix. Here the diagonals are equal. So when you come to the next one, B, that is 3 cross 3 matrix. Here also when you see all the diagonals are equal. Next one is an identity matrix. Here the same like the scalar matrix. There the diagonals are equal. Any numbers we can use, but here in identity matrix, you know, identity means it means 1. So here you have to use 1, okay. So I am taking an example Aij, that is 3 cross 3 matrix. So the diagonals are 1. In 2 cross 2 matrix also you can take, that is diagonal should be 1. That is the identity matrix. Next one is an equality matrix. Here a matrix Aij m cross n is said to be equal. There are two conditions. If both the matrices A and B are of same order and size, then the corresponding entries in both the matrices A and B are equal. Of both the matrices A and B are equal. So here example, when we take x, y, z, w, when you see this, first one is fulfilled because in A and B both the same order and size also. So order is 2 cross 2, here also 2 cross 2. The corresponding entries in both the matrices A and B are equal. So here when you compare, you can write like x is equal to 5, you can write x is equal to 5, and then you can write y is equal to 4, and then you can write z is equal to 3, then w is equal to 6, like that you can write. So here the corresponding entries in both the matrices A and B are also equal. So next one is a null matrix. Here A is equal to Aij, 2 cross 2 I am taking. Null matrix means there should be no numbers, okay, everything should be 0. That is the null matrix. Next one we are going to see about the transpose of a matrix. Next one, we are going to see about the transpose of a matrix. As I already told, the matrix obtained from the given matrix by interchanging its row into column and its column into row. So that is the transpose of a matrix. So we can denote that as a dash or a power t. So that is a transpose we are denoting. A transpose we are denoting. So for example, we are taking a matrix, that is A is equal to 4, 3, 2, 5, 6, 8. Okay. So this one I am going to write in the transpose. This row I am making into column, and then second row I am making it into second column. So this is how you have to write the transpose. Okay. That is called the transpose of the matrix A. So the A transpose is the transpose of a matrix. Next one is the multiplication of a matrix. So here 2A. So when you're multiplying 2 with the matrix, for example, that is 2A. So 2 into Aij m cross n. So I am taking a matrix A, that is 4, 5, 6, 3, 2, 1. Here I am going to multiply 2 inside. Okay. So when I multiply 2 inside, I will get what? Yes, good. 8, 10, 12, 6, 4, 1. So this is the multiplication of a matrix. The same like the subtraction of the matrix will come. When we come to the subtraction of a matrix, A is equal to Aij 3 cross 3. So I am taking minus, just we are adding minus. So when you take the minus you have to take it inside of the matrix. As how we multiply 2 inside the matrix, now we have to take the minus inside the matrix. So inside the matrix you are taking minus. So minus 2, minus 5, minus 6, minus 4, minus 3, minus 2, and minus 5, minus 2, minus 1. So this is the subtraction of a matrix. I hope you understood. Thank you for listening.